Welcome to this session, build a system with the file system maintained by OSTree, or a version controlled file system maintained by OSTree. I'm Pan Jianhong and comes from Endless SS. And you can find me on GitHub. My ID is star9, and I will put this slide to the slideshare too. This is the agenda. When we're talking about an application, it usually composes 3 parts: the execution code and the configuration, and maybe the data. Execution code will read the configurations and may need some input or output data. Operating system is a big application too, and here's the OS file system hierarchy standard provided by the Linux Foundation. The first one is the /, which is the root directory, of course. And then etc is the system configuration. Bin and user bin and the user folder usually have the execution code. And the home var and the run folders are data related. So what if the execution code and configurations can be maintained by a version controlled system? OSTree might be the solution. It's an upgraded system for Linux-based OS that performs automatic upgrades for complete file system trees. The premium model is composing packages on the server, then replicating them to the client. The underlying architecture might be summarized Git for operating systems binaries. It operates in user space, and so it will work on any top of the Linux file system. And the Git-like content address object stored with the branch or as known as a reference to track the meaningful file system trees within the store. Similarly, one can check out or commit to these branches. Here are some projects that are using OSTree. For example, one of the Linux package management system Flatpak, and some Linux distros such as Fedora CoreOS, Silverblue, and Fedora IoT. And a desktop operating system, Endless OS, use it as well. And I'm an Endless OS maintainer. Some automotive-grade Linux Raspberry Pi image use the OSTree too. Now, because we are going to use the OSTree, so we have to install the OSTree package, of course. And I'm going to use the Alpine Linux as the following examples. So let's have an Alpine container first. And we are going to use the Alpine, so we use the apk add OSTree to install the OSTree package. Now, just like a Git initiate, we can use the OSTree init to initiate an OSTree repository. The -- repo here means the repo is a OSTree repository. And if we check the folder, there is a config file here. It's just like a git config. And now we can prepare some data in a source folder. So for example, we make a source folder and then put a hello world text file into the source folder. And then we can use the OSTree commit the source folder with the subject test commit 1 to the full branch. Just like git commit, yes. And then we have the commit in the full branch, so we can use the OSTree log full to see the commit here. And here's the test commit 1 and the hash code. And we can even use the OSTree reference to list the branches. And right now we have the full branch. We can even use the OSTree ls to list the the last commit of the full branches file system. For example, we can see there is a hello text in the latest OSTree commit. And we can use the OSTree cat full hello text to see the content. It's the hello world text. Now we can use the OSTree checkout full branches. It will check out the latest OSTree commit on the full branch to the tree checkout folder. So we can see the tree checkout folder here has the hello text, and the content is hello world. Now we understand how to use the OSTree command, so we can try to build a file system maintained by OSTree. And I put an example on my GitHub repository. My ID is star9, and the repository is the OSTree build FS. You can scan the QR code to get the code. Okay, here's the flow. The first step is build the file system as an OSTree commit, and then we can push the OSTree commit to an OSTree repository server, and then the image builder can pull and deploy the OSTree commit as a file system from the OSTree repository server, then make an OS image. And some deployed system can use the OSTree admin upgrade to get the latest OSTree commit from the OSTree repository server. Let's talk about the OSTree repository server first. It composes of 3 parts. It has 2 surfaces. One is the SSH server, and the other one is the HTTP server. The SSH server is for the connection from the OSTree source commit client. It must allow TCP forwarding and gateway ports for the SSH tunnel built by OSTree push, which means OSTree push via the SSH to the then the OSTree commit will write into the OSTree repository storage. And according to OSTree's document, the archive format and the archive efficiency, storing content in archive mode defined in the config file can be served directly over a plain HTTP static web server. So here's why the HTTP server. And the image builder can use the OSTree pool to pull the OSTree commit via the HTTP protocol, and the OSTree admin upgrade can be executed on the deployed system. You get the latest OSTree commit from the OSTree repository server. It works over the HTTP too. Now let's try to build the file system as an OSTree commit. Before do that, we must prepare the environment to build the file system. And I'm using the Alpine image as an Podman container. And it must install the OSTree push to push the OSTree commit. Now, to build a file system, we have to bootstrap a root file system to a local folder, and then generate the initial manifest, including the OSTree module. And we have to install some customized parts. For example, the initial manifest init that will be packaged as the initial manifest init script, and then some OpenRC services. For example, the OSTree after boot OpenRC service for boot run label, and the OSTree finalized stage service for shutdown run label. We will talking about them later. And we also have to follow OSTree's deployment to prepare the boot user file and the sysroot folders. And then make the file system as a new OSTree commit, of course. Then OSTree push the OSTree commit to the OSTree repository server. Now let's talk about the OSTree push command a little bit. It is created by my colleague Dan Nicholson, and the idea is have a copy of the OSTree repository from local to remote SSH server with the stage feature of objects. It's just like a git push over the SSH. And recap, we are going to using the OSTree pool again. Here's the sequential diagram. And we have the OSTree source commit client and the OSTree repository server. And the client runs the OSTree push to push the OSTree commit. But it starts a local HTTP server first on the client. And then OSTree push initiates an SSH connection and builds an SSH tunnel between the OSTree source commit client and the OSTree repository server. And the local HTTP server on the client, the HTTP listening port is tunneled via the SSH. So the OSTree repository server can run the OSTree receive to pull the OSTree commit over the HTTP request, which means OSTree receiver will run the OSTree pull to pull the OSTree commit from the local HTTP server on the client to the OSTree repository server. So here's the HTTP communication here, HTTP request, HTTP response. After that, they synchronize their OSTree repository between the OSTree source commit client and the OSTree repository server. And after synchronization, the client stops the local HTTP server, of course. To make OSTree push works on the Alpine Linux, I submit the merge request to Alpine. And here are the requests. And they all have been merged and available within Alpine Linux right now. Now let's talk about the image builder to build the image. I use a virtual machine as the build environment, and it's an Alpine VM, of course. And the environments install the OSTree and the multipath tools and the SF disk packages. The idea is, the first step, create a raw disk image and the disk image with 2 partitions and label them as the boot and the root partitions. And then create a target folder, and which is going to be mounted for the root. And the boot partition will mount to the target boot. And then create the local OSTree repository into the target folder and add the remote OSTree repository address to the local OSTree repository, just like git remote add. And then we can pull the OSTree commits from the remote OSTree repository server to the local OSTree repository. And then we can deploy the OSTree commits to local folder, the target folder as the file system. And then prepare the bootloader and related commit. And we are going to use the SysLinux as the bootloader. And we have to prepare SysLinux related configurations and files into the boot partitions. And I have make the steps as the make image. Now let's go to the example. Here's the OSTree repository server. I have a server cluster YAML. It contains the web service and SSD service. And they all can access the OSTree data here, OSTree data. So that's where the OSTree repository server stores the OSTree repository. Now let's run the OSTree repository server. And then we can try to build a OSTree commit and OSTree push to the OSTree repository server. I prepare the script here, OSTree commit push. And the SS user is OSTree job. And the server is localhost. Port is 2222. And the HTTP port is 8080. And the branch is OSX 8664 man. Now it bootstraps the target folder with the Alpine bootstrap. And after that, it will commit it as an OSTree commit and then push to the OSTree repository server. And it runs a little bit time. Back to the slide. And when we try to OSTree pull the branch from the OSTree repository server, if the OSTree is not signed with an available GPG key, it will show an error, GPG verification enabled, but nothing in nature found. So we have to add a workaround, no GPG verify parameter to the OSTree remote add as a quick workaround. And however, please sign your OSTree commit in production environment for security. Now deployment. OSTree deployment. it push the OSTree commit we just built to the OSTree reply server. After that, and after that, that we can do the make image here. This one. I have a Alpine virtual machine. Now I have to mount the IP share folder from the host. Then I have the script make image -h here. Now I have to add the indicate where is the OSTree repos server within URL. It's a HTTP 10.0.2.2 8080 ports, and then repo. Why is the 10.0.2.2? Because here's the virtual area network. Virtual network area, and OSTree repos server has the IP 10.0.2.2. This one. And then the branch is OS x86 64 man, and output as a disk image. Now you can see it pulls down the OSTree commit from the OSTree repos server and then build the image. Now the image is built, and we just built it here. And then power off. And we said we try to pull the OSTree commits here and deploy the OSTree commit. And the related command you can see script. Oh. Script make image here. OSTree admin initiate an OSTree repository, and then OSTree pull the OSTree commit from the OSTree repository server here, and then OSTree admin deploy the OSTree commit to the sysroot here. Which is the target folder. Target dir is the target folder here. This one, yeah. Okay, the deployment. We just said the OSTree admin initiate and deploy. Just use the OSTree admin blah 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 command, and the core content of these operating systems are treated as read-only, and they transparently shared storage. And the deployment is physically located at the path of the form OSTree deploy and the state root deploy and checksum. And the state root is the Alpine here. OSTree is designed to boot directly into exactly one deployment at a time, which is deployed by the OSTree commit. And each deployment is intended to be targeted for a change root or equivalent. By default, OSTree's hook creates a read-only bind mount over user folder. OSTree maintained the immutable user folder increases consistency and robustness. And OSTree does not touch the contents of var folder, and the OS components such as daemon service are required to create any directory they required there at the runtime, and also if in its upgrade. The OSTree must include the kernel and initial manifest, of course. The current standard location for this are under user, lib, modules, and the kernel version, and VM lineage as the kernel image, and the initial manifest image. When build the OSTree commit, OSTree deployed will put them into a corresponding boot OSTree and then the hash code folder. And except the var and etc, the rest of the contents of the tree are checked out as hard links into the repository. And in summary, user folder is immutable, and var and etc are writable. And this is the important feature. Now let's talk about how the system boots out from the chip to our OSTree deployment. When the chip is powered on, it loads the firmware and runs the firmware, such as the BIOS or some special firmwares. And then it will load the bootloader and runs the bootloader. And the bootloader will load and run the kernel and initial manifest. And the kernel will try to run the first process init. And some systems make the firmware load the kernel directly, but we are using the SysLinux as an example here. And the bootloader's configurations and the kernel, deploy the kernel and initial manifest, and after that, including the initial process, can be maintained by the OSTree commit deployment. Okay, we just talked about the SysLinux as our bootloader, but how does SysLinux find the kernel and initial manifest to boot? So we have to prepare a SysLinux config. Actually, OSTree deploys the boot entries under the bootloader entries and with the OSTree blah blah blah.config file. Oops. So we can use I prepare a script OSTree SysLinux config to parse this file to get the Linux and initial ID and the options. And this is the item name, title item name. So we have the information, then we can get it into the SysLinux config. So kernel is the kernel here, and the initial ID is the initial ID here, and append is the options. And kernel indicates where is the kernel image, and the initial ID indicates where is the initial manifest. And append, there's a special kernel boot option, OSTree here. It indicates to the where is the real file system we are going, real file system deployed by OSTree commit, and we are going to pivot to. If we check the information in the SysLinux config here and trace the folder, we can see the boot OSTree Alpine 7 blah 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 includes the initial manifest and the VM lineage, just as mentioned here. And if we trace the OSTree boot.1, it comes from here. The path and the trace to the real, we can trace to a real deployed file system here, and we are going to use OSTree going to pivot as the real root folder. And if we check the Linux kernel's documents, the boot commands parameters, we understand that the default init process is the sbin init, but in the run disk or initial manifest, the /init is the default script or executable application. And if we decompress the initial manifest, we can get a small file system here, and it will be mounted temporarily for the kernel when boot. And you can notice there's an init script. And it actually is a shell script, so the shell is linked to the bin busybox, and here's the real busybox in the initial manifest. And I prepared a special section. The init script is actually packaged from the init manifest init script. and I just modify it and customize with by adding a special sections here. If there's an OSTree kernel's boot options, then it will run get into this if condition. The first step is find the two partitions, the boot and the root partitions on the disk image, and mount them to the sysroot folder and the sysroot boot folder. And they are formatted as the ext4, so we must load ext4 module as well. And here's the key point. We use the OSTree prepare root command to pivot the real OSTree commit deployed file system to the sysroot, and the real root file system path is indicates in the OSTree boot options. So OSTree prepare root will get the OSTree environment variable here. And then another thing is the ROM folder will be cleaned by OpenRC boot misc service. So we have to move the OSTree booted file to the var temporarily. It is a flag. File acts as a flag for the OSTree mechanism, and we are going to use it later. And you may think, what's the difference between the traditional packaged maintained system. The traditional packaged maintained Linux system just pivot the original root to the root directory. However, in the OSTree maintained file system, it will pivot the subdirectory to the as the root folder, which is OSTree deployment. And to make the OSTree work in the initial manifest, I submit a related merge request to Alpine2, and they all have been merged and available within Alpine Linux right now. So we have to add the OSTree module into the make init fs config, and it will bring the OSTree prepare root and the related dependency into the initial run manifest. If you check the boot log, you will notice there's a text setup OSTree file system. It mounted and pivot to a real root file system by the initial run manifest init. And after initial manifest finished, you will hand over back to the kernel, and the kernel will try to run the first process sbin init. And if we check the sbin init, it actually links to the busybox. And the busybox, if you read the busybox document about the init, it reads the /etc init tab, and the init tab will run the OpenRC. So we can see here's the OpenRC, and it brings up the OpenRC services. And you can notice there's a text rebuild me the target for OSTree file system, which is comes from the OSTree after boot service. And if we get into it to check more in detail, we can notice it makes some folders, including the home folder, and it links the home folder to the var home. And one important thing is it retrieved the OSTree booted file back, which was moved by the initial manifest to the ROM folder. And then due to the OSTree booted file, so we can understand that the file system is OSTree booted. The information comes from OSTree admin status -v. Now, let's run the image we just prepared. Okay, you can notice here is the setup OSTree file system and rebuild missed targets for OSTree file system. And if we run the OSTree admin status-v, yes, we have the OSTree booted file, and the root is OSTree booted. And we can see the deployment. OSTree deployed. Yeah, here's a real root file system we are using right now. And yes, back to the slide. And then how about the deployed system? We want to update the OSTree commit if there's a new one. And if there's a new commit pushed to the OSTree repository server, then OSTree deployed system can upgrade the commit by the command OSTree admin upgrade. And if we check the OSTree status, you will notice there's a new commit, but in the pending. And the stars here means here's the OSTree commit that we are using right now. And the pending OSTree commit means we are going to use it for next boot by default. And actually, if we check the bootloader, especially the entries, OSTree admin upgrades will provide the two boot entries, which one is the original one we are using right now, and the other one is we are going to use for next boot. And they all contains the kernel and the initial RD and the append related information. And the OSTree admin upgrade also updates the syslinux config at bootloader syslinux.config. And we can replace the original original boot syslinux/syslinux with this new generated configuration. And here's the new syslinux config. How does it look like? And this is the new OSTree deployed information we are going to use for next boot, and the green is the we are using right now. After upgrade OSTree commit, but before power off. During power off, the customized OpenRC service that we prepared, OSTree finalized stage service will finalize the OSTree commit deployed by OSTree admin finalized stage and update the OSTree's config. Cat clear cat etc oh, this one. Cat etc and OSTree finalized staged. Here's the OSTree admin finalized stage, and replace the syslinux config with the new configuration. So, yeah, here's the OpenRC service. So the next boot will use the new deployment by default here. Here's the special things that I want to share. For the OSTree maintained file system, for example, we want to APK add the new packages such as a Git. You will notice it will fail, which means you cannot modify your file system content. So it avoids some unexpected behavior to crash your system. But how to add another package in your system? The solution is go back to your OSTree commit, go back to your build OSTree commit, and then, for example, vin script boots package git. And OSTree commit push. Yeah, you have to build the OSTree commit again and then push to OSTree reply server. So there's a new OSTree reply server. So you can use the OSTree admin upgrade to upgrade your OSTree deployment to your system. Then you can have the new package. So it's just like a container that you have to add another layer on top of your system. Now, how about the configuration etc folder? The three-way merge is performed between the currently booted deployment etc and its default configuration and new deployment based on the user etc. As soon as you modify or added a file into the etc folder, this file will be propagated forever as is across the boot. You can use the OSTree admin config diff, it's just like diff, to have the difference between them. Summary. OSTree's underlying architecture might be summarized as the Git for operating system binaries. And we have an OSTree repository server, and learn how to build an OS file system and make it as an OSTree commit. Then push the commit to the OSTree repository server. And we can pull the latest OSTree commit from the OSTree repository server and deploy it as an OSTree maintained file system. We learned how to chain the boot from the chip bootloader kernel and initial MFS to the file system and deployed by OSTree commits. If there is a new commit, we can do automatic update, then have the new commit deployed by the OSTree, including kernel and initial MFS at the next boot. And the OSTree maintained file system increases consistency and robustness. And here are some reference. Any questions?也可以用中文问啊。
没有，你再大声一点吧。你要等他一下。
好。所以就是 file system 跟那个 init_d 的那个关系是什么？就是我知道，就刚开始那个 kernel 开机完会进到 init_d， 然后接下来就是
每一次 OSTree 破一个之后，就会写出一个新的 file system， 但因为它用 hardware， 所以它们会 share space。那你的 initial remedies 要知道说你有一个新的 deployment 可以开进去，但是它预设会留2版，所以新的那版如果你开失败，可以 roll back 或者。
sorry， 对，这是想知道的问题，对，抱歉没有，了解。
所以问题是，
没有，就可能我对 file system 这一块就是还没有到太了解，就是sorry。
I have to say, I skip many things in detailed things because the time limitation. But if you have a question, you can just ask. 就是我略过了很多东西，因为它这个是背后组合了很多的各种的知识，因为它是一个组合技，它不是单纯的一个东西，所以如果你有就是详细的问题的话，其实是可以问的。
你刚刚说你不清楚
我不清楚的是一些比较基本问题，像是init_d 是用来干嘛的？
你讲 init_d 是哪个 init_d？ 是 initial MFS 里头的，还是
就刚开始开机的那个 PID 唯一的那个行程？
它是 init 不是 init。init 我们想到古早年代的，
哦 ，sorry。
Okay. Let's trace the Linux code directly. Here. Oh, not this one. Okay. When the kernel boots up, it will run something, and it will run the init script in the initial runfs to build a small file system for the kernel. Sorry. Initial runfs is a small file system for the kernel when boot time, and there's including an init. It could be a script or a binary, an executable binary, and it will run by the kernel. And here's the and here's the init script. Init script can do something. For example, remount your real root file system. After you have the real root file system, it's a full file system you are going to use later. And then here prepares a real root file system we are going to use, but have not yet. And then cat data make initfs initial runfs. It will run a command which means a switch root to switch the root file system that we are going to use. So this current root file system provided by initial runfs will be dropped because we already switched root to the real root file system we are going to use, and then back to the kernel.
Do you know what is Redis, or should we explain to you what is Redis? 你知道什么是 unique RD 或者 Redis？ 没关系。
好，没关系，我再。
So nowadays that Linux boot up was split into two phases. The first stage is called initial run file system, because modern days we have many complicated code media such as, for instance, your root file system is residing on some sandbar or very weird network connections. So the Linux kernel will require init runfs to bring up the boot median. So the PID equals 1 is actually a script inside the runfs to do the housekeeping. And after that, it will use a system called switch root to switch to the real boot median. And the PID is no longer the PID equals 1 because it's okay, that'll be too complicated. So that's the case. So yes, 还是你讲好了。
Basically, it finds the next stage and loads it.
When you prepare the real root file system and switch root to the real root file system, then the real root file system, including the real spin init in the real root file system. So the kernel can load and run the real spin init as the first process, the PID1. 对，就这样一个 stage 啦，就是你要先在 initial runfs init， 它只是先把真正我们之后要用的那个 file system 把它 mount 到一个地方，然后我们再把它切换过去。对，就 switch root 做的动作。
对，因为这里面同时你的那些多媒体很复杂，可能是一个网络上不知道哪一个 NAS 或者什么东西的。然后所以说，它会先有一个在放在 run 上面的 file system， 先帮你做完这些该做好的你出来，然后把你的 root 放在某一个地方，比如说写new root。然后 Linux 有提供一个特殊的 system code， 它不是全部都是 switch root， 那可以帮你把你对根目录的理解直接换成是某个的 directory。那
就是 OSTree 它你可以想象它把那个 user 这个 folder 啊，它把它做成就是有 version control， 然后它是 user 是没办法移动的。那除非你要移动的话，就是要重打一个新的 OSTree commit， 那 push 到 OSTree repository server 的，然后再 pull down， 然后 OSTree admin upgrade 的时候会重新 deploy 新的 OSTree commit 到那个 file system 上，然后那个 sysconfig 啊，它就会更新。sysconfig 它就会 syslinux 的那个 config 就会更新。
可是我觉得为什么这 config 没有备份，我觉得好恐怖。就是这 syslinux config 就是 floater config 为什么它没有存个点 backup 之类的，还是要 rollback 这个的话要怎么
Okay, we can build a real OSTree commit again. The question is how to do the rollback.
of the syslinux bootloader config? Because you just override it with the new one. So where's the old one? Is that, or is it logged in the previous commit? Or sorry, I'm a little confused by here.
Okay, let's boot a new OSTree commit and push to the OSTree repository server, and then wait it. Okay, we have a new OSTree commit on the OSTree repository server right now, so we can use the OSTree admin upgrade. Okay, right now we have two OSTree deployment here. One is pending. The other one is we are using this one right now. And if you check the OSTree deployment, alpine deploy, you will notice there are two OSTree commit deployed file system here. And yes, and right now the 8.3 blah 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 is this one, and the 6.3 here is we are going to use it for next boot.
Sorry.
Now they all have the real file system we are going to use. And right now, we have a new bootloader. Now we have two boot entries here. OSTree.1, S-1, conf, and 2. Okay, cat boot loader entries. Oops. Now we have the two boot entries, OSTree-blah blah blah.conf. One is old, the other one is a new one we are going to use. And actually, OSTree admin upgrade provides this syslinux config for replacement cat boot loader syslinux.config. So you can see here are two boot items. One is the we are using currently, and the other one is the new one we are going to use. But, yeah, 关键就是这个 but. OSTree booted. You may notice there's a booted.0.1 and the boot.0. Yeah, we have to OSTree have to do some special thing to link the real OSTree deployment. So that's why we need the etcnd tab OSTree finalized stage. That's why we need the OSTree finalized stage here. The OSTree admin finalized will finalize the staged information here to update the link. And then we have to replace the current boot syslinux to the new one. And so we can even use the diff boot syslinux config, and the new one is the boot loader syslinux. Now you can see here's the difference. And then right now we are going to power off the system. You can see OSTree finalized stage runs, and let's power off, power on. It boots quickly. You notice new two boot items, and the default one is the new deployment. OSTree admin status. Okay, we have the two OSTree commit, and we are using a new one right now.
Okay, any other questions? One question from me though. So I've been using Fedora Server Group as my main development machine. So I've been getting quite used to this system. Do you use an OSTree system as your development machine?
Actually, I use Arch Linux as my development environment, but I maintain the Endless OS, which use the file system maintained by OSTree.
Okay. So on your development machine, you still want package management and
Because
modifiable root, right?
yes, because I'm an engineer, this is more for OSTree is more like for production environments, such as for school, and maybe for finance organizations.
Like Chromebooks or
Yeah,
appliances.
Yeah. For robustness and consistency.
The actual developer experience is very much like a Mac. So if you come from a Mac background, so like Fedora Server Group, actually a lot of people use Homebrew to install the command utilities when you use the system. So CoreOS just is latest and modifiable. Like you add your utilities using Homebrew inside Homebrew.
Yes, it actually, when you add a new packages, it will add another OSTree commit layer on top of it. So, yeah, then reboot, and then you can have it. If we still have some time, I have an appendix.
I think we have one more question.
Yeah.
We talked a lot about the deployment. Is that the most important part of OSTree? Because I feel like that is the only part that is different from what we can do with Git, like all the version control, distribution, and like even in Git we can have a Git hook to do the things. So what is so special about OSTree?
It makes your file system maintained by a version control system provided by OSTree.
So I guess your question is like, can you use GitLF as for something like to do it with your bare hands? Is it okay?
Yes, something like that.
Yeah.
So like from the feature I see, maybe I can do it with Git scripts in like few days.
Yeah.
What is the thing that I cannot do in that few days?
First, you have to prepare the ecosystem by yourself. And that is the most important part. And someone already have done for you, it's the OSTree.
It's just the same question as like Docker. You can basically Docker namespace and some very fancy ass network configuration and stuff like that. And you can do it with your backend with scripts and stuff like that, but with the complete ecosystem that other people set up for you, that's completely different story. You can do it, of course. As far as I know, there is a project called Bocker, B-O-C-K-E-R. It means that you use OSTree all the way to do all the things that Bocker can do. But nobody maintains Bocker. So it's just the same thing. You can maintain the file system with Git LFS, of course, but nobody will maintain it for you, and it will be a one-star project on GitHub, I guess.
Yeah.
Okay, maybe I have similar thoughts on that. Like, I mean, let's turn it the other way around. Like, why are you not using Git as a server? Why have you built your own server component?
You mean Git server?
Yeah, like on this, you had this on the server side. You talked about like you have like an SSH tunnel, and then it logs into that server repository, and then you do like a reverse HTTP request, and then you have HTTP service. Like all of that exists with Git already. Why didn't you use that? Why did you build that yourself? Or are you using Git underneath? I mean, I understand like here on the bash level and the init integration. Yeah, sure, you have to do that. But on the server side, why did you reinvent the wheel? It looks like.
It's like Git, but not fully Git. I mean, you can just make try to make maps to the Git, the idea. I only say the idea, not the real implementation is the Git. Yeah.
Yeah, I understand. Like, but why? Why did you do it? Why didn't you just use Git? Like, there must be a reason, right? Like, because this is faster, or this is better, or this is smaller, or this is bigger. Like, what? Why did you do it? Why do something new if Git is already there?
It's still already there. But what's still already there?
Maybe Git has not provided Git LFS before the OSTree starts.
Or OSTree is very old. I don't know.
In practice, OSTree is a bit faster. It's, the main author is this Colin Walters developer, employed by former Red Hat, now part of IBM. So this is mainly Red Hat.
It's faster than XCI. So there was a performance.
The performance being by the whole of us in image. I was thinking about actually why is that moving so much faster?
Thank you.
So
如果还有一些时间，刚刚
you want to demo something? Okay. 'Cause, well, we better make it quick because I guess the stuff will storm here.
Okay, that's the one. We just talk about add more applications on top of our file system, but it is we cannot do that unless we use the OSTree admin unlock. It will add a temporary writable layer on top of your user folder, so you can modify your user folder. For example, apk add blah 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 packages. However, right now on this demo, it does not work. I don't know why, but for other distros such as Debian or Endless OS or Silver Blue, it could work. Yeah, it works. Yep. But there's a magic command OSTree admin unlock for it. Yeah. Thank you.